Hello everyone, today I will introduce you to our in-app AI-based 1D and 1.5D nesting solution inside CMXC. This feature set allows to perform the classic nesting or material optimization operations. We allow the user to play with different parameters, run the optimizer numerous times to study and settle on the best optimized cut list. So without further ado, let's jump into the product and show you how you can achieve this. Here is the 3D fabrication model that I will be performing material optimizations on. For this stick build curtain wall project, there are multiple heavy mullion extrusions that need to be fabricated. One such extrusion is shown here. Now let's take a look at how you can easily optimize the material use for all such extrusions in this project. Navigate to the nesting tab on the left pane, and this will bring you to the nesting page. Next, you can click on the plus button at the top and select Add Nesting, or you can click on the Create button on the top right corner to create a nesting job. Nesting job are a group of parts that you need to optimize stock material for. Make sure to group similar part profiles for nesting. The different part profiles can be identified by the part type set during the project setup or from the part name. Now here you can define a nesting ID, which is a name for your nesting job, and if you have a specific material profile for that job, then you can also add a material ID. Something else to note that if you're using any off-the-shelf material optimization application, you might have to insert your bill of materials one after the other before you can even optimize. However, in CMXC, all the information, including the part length, material type, is extracted from the 3D BOM, hence you only have to choose and insert the parts in the nesting job, and from there you can start optimizing. Now you can search for the part using the search tab. Once you have the part, you can then click the right arrow, select the quantity, and press the green check button to add it to the nesting job. Similarly, add all other required parts into the nesting job. And once done, you can click on the Create button to create a new nesting job. In this window, you can see the part list, and here you can also define the miter cuts for selected parts. First, select all the parts that need miter cut, and then click on Set Miter Cut. In the Edit Miter Cut window, you have the option to remove parts and set the miter cut boolean to yes or no. Once done, click on Confirm, and now you can view the miter cut value is changed to yes in the parts list window. Click on Next to move to the next stage, which is Nesting Settings window. Here you can add stock material and set different nesting optimization setting. Now to add a stock length, click on Add Stock. In this window, you can define a stock ID, length of the stock, and the quantity available in your inventory. You also have the option to add a cost to determine if the final optimized stock order cost is different for various stock sizes, and also you can add any notes if you want. If you want to add another stock, you can click on Confirm and Add New. Otherwise, click on Confirm to move to the next step. For the purpose of this demo, I will be adding 2 more stocks. Now notice here you can always go back to edit your stock length settings by clicking on the 3 dots as shown here. Now let's run the first nesting without any optimization settings and see how the result comes. Click on Start Nesting, and now you can view your first nesting result. The algorithm has automatically picked the best stock length, which minimizes the waste rate and the amount of material used. Let's run another nesting with different set of parameters. Click again on Nesting Settings on the top, and now I can manage my nesting settings. You can input buffer length for miter, where you can define a block sizing value for each of the pieces. The system will add the offset value for straight cuts before the actual miter cut to each and every single piece with the boolean set to true. Here, I will input 2 inches. Next, you can define the thickness of the blade. Here, it is 0.25 inches. Next, 2 inches for defining the end trims, and 1/6 for tolerance. Once done, I will click on Start Nesting. Now this is the second nesting result. You can view the waste rate, and if you want to compare from the previous result, you can click on Load Previous Result option and can toggle between Run 1 and Run 2. Likewise, you can have 4 to 5 different runs, and once done, you can click on the Load button to load the run that you want to proceed with. Once complete, you can view the cut list digitally or print it out using the Print Cut List button. You also have the option to print the part labels. Click on these options, choose the print settings, and simply click on print. For example, a saw operator can print the cut list and use it in a paper format to cut the pieces, and then can stick the printed part labels on each of those respective pieces. After picking the best results from your nesting runs, you can then feed this optimized cut list into our digital part traveler. Part travelers are forms that have single QR code and single workflow to track multiple parts altogether. To create a part traveler, you can click on the plus button at the top, or simply click on the job orders from the left pane and then click on create. Job orders are logical grouping of part travelers based on either the extrusion profile or the scope of work. One job order can have one or many travelers, and also one job order can be associated to one or many cut lists. Click on create button, input the job ID, click yes to create travelers from a cut list, select the nesting ID, and then click on create job. Now click on create traveler, choose the cut list, and then click on next. Now select the traveler type. Here it is already selected as there is only one available for this project, and then click on confirm. In this window, click on new traveler button to add a new traveler. To add the parts that you want to track using the traveler, select the parts and then click on insert to traveler. Now in this window, you can use the maximum quantity feature to insert a maximum quantity, say 10 parts per traveler. The maximum quantity can be defined depending on the capacity of the cart used to move these parts around in the factory to which the printed part traveler is attached. Once you check the box and input the maximum quantity number, click on insert parts and the parts will be added to the traveler. Depending on the parts quantity per traveler, you can now see the number of part travelers created. And if all looks good, you can go ahead and click on the save button at the top to save the traveler. If you save the traveler, you can always go back and edit the traveler again, as you can see here. Click on the three dots and then select edit traveler, and this will bring you back to the traveler window. Now here, you can go to the digital traveler for any part and edit the quantity for that part, or you can also go and remove that part from the digital traveler. If there are no more changes required, you can click on Save and Release All button, and this will release the traveler ready for tracking using a single form and a QR code. Now you can view the traveler under the Form tab. You can print this by clicking on Print Preview. Next, to update the status, simply scan the QR code on the paper, and that will bring you to the status change window. Hit the green button to update the status, and the status will be updated for all the parts inside that traveler. Now to view the status of the parts, click on Dashboard, then Job Orders, and here you can view the status change updates in the form of pie chart as well as tabular data. So this is how you can nest your parts inside CMXE and track them later via digital travelers. Thank you very much for watching this video, and if you would like to learn more, please visit our website www.cmxe.io.